Hi students, welcome to Darasa Online. My name is Naftal Lucas Makumbire, a chemistry teacher. Now today I want to review with you Form 4's student the topic which is called organic chemistry. And the subtopic that we're going to discuss is about alcohols. Alcohols. So this one, this subtopic is also very important because sometimes you are going to meet with the questions that need you to write the chemical, the chemical reactions. So this particular subtopic will give you the knowledge on how to answer those problems. I'm sure that by the end of today's lesson, you are going to be very confident and very comfortable in solving different problems relating to this particular part. So there is no need of worrying, as most of the students are worrying and they are fearing when they meet with the questions coming from the organic chemistry, and particularly today because we are going to discuss about alcohols. And also they can have the knowledge. Some of the students have the knowledge of this subtopic, but how to answer the questions, it is a problem. So connect with me from now onwards to see how the question can be solved, but also to get the knowledge that will enable you to be competent in solving different problems. Now, as I've said that we are going to discuss about, the topic is organic chemistry, right? And the subtopic is alcohols. So let us start to define about alcohol. What are alcohols? That is the first question. What are alcohol? That is very, very important. So, in order to start this one, the discussion today will enable you to investigate the properties of organic compounds and the applications in daily life. Now, what is alcohol? Alcohol, these are organic compounds. Organic compounds, these are organic compounds containing hydroxyl group as the functional group. The functional group. Yes, these are organic compounds containing hydroxyl group as the functional group. So, in short, this alcohol can be represented as R or H. This R represent alkyl groups, and this is hydroxyl group. Now, do you remember when you talk about alkyl group? When you talk about alkyl group, to remind you, alkyl group is an alkane. Is an alkane with one less hydrogen atom. Hydrogen atom. So you can see here, alkyl group is an alkane with one less hydrogen atom. So when you put R, this represents alkyl group, and this is OH. You can have an example. For example, methane here, methane which is CH4 can give CH3. This is methane, and this is methyl group. Methyl, it is written this way, methyl group. Now, so this is the methyl group. So we can have an example. For example, instead of writing R, we can have that example, maybe this one, OH. So this is an alcohol. Therefore, it is very simple for you to define alcohols in this way. Now, alcohol are classified into classes. Here we talk about the classes of alcohol. It is also important to know the classes of alcohols. We have the first one. We have primary alcohol. Primary alcohol. Primary alcohol, this one, the carbon which is containing the hydroxyl group is bonded to only one carbon atom. That means carbon bonded to hydroxyl group. Sorry, carbon with hydroxyl group. Carbon with hydroxyl group is bonded to only one carbon atom. Yes, primary alcohol. It is important for you to know these classes. Now, example of this one. Examples, for example, we have this one, CH3, CH2, OH. Look at this carbon. This is the condensed structure. If we write in open structure, it is like this way. This is the OH, this hydrogen, and you can see here. So this is the carbon with 3 hydrogen atoms. This carbon with OH group, hydroxyl group, is bonded to only one carbon atom. So this is the primary alcohol. The hydroxyl group is present on the first carbon. That is example number 1. Example number 2, we have this one. This is called ethanol. We are going to see about the homologous series of this alcohol very few minutes to come. This one. So this carbon, if we write it in open structure, it is like this way. OH. So you can see this carbon, which is containing the hydroxyl group, which is the functional group of alcohol, is bonded to only one carbon atom, which is this one. So it is very simple for you to do that. Now, going to another class. Going to another class of alcohol. The second one, we have secondary alcohol. Secondary alcohol. Secondary alcohol, this one, carbon with hydroxyl group is bonded to other 2 carbon atoms. To other 2 carbon atoms. So I can give you examples here. Examples of this one. Number 1, we have this one. Can you see this example? If we write this the condensed structure, if we write in open way, it is like this way. This carbon with 3 hydrogen atoms bonded to this carbon with 2 hydrogen atoms as they appear. Now this carbon with hydroxyl group is bonded to 2 other carbon. So you can see here, this carbon has got the hydroxyl group. It is bonded to carbon number 1, which is this one, and carbon number 2 is this one. So this is secondary alcohol. It is very simple for you to know it. Now, I can also give you the last example of that one. The last example, we have this one, we have this one, then that one. This one. We are going to see the homologous series. There is no need of worrying. This is the secondary alcohol. If you come to this class, as you can see if you write the open structure, this carbon with 3 hydrogen atoms in that way, and this carbon with hydroxyl group that way, it has got another hydrogen there, then this carbon with 3 hydrogen atoms. So this carbon, which contains the hydroxyl group, is bonded to 2 carbon atoms, the first carbon and this the second carbon. So this is secondary alcohol. Then the last one is tertiary alcohol. Tertiary alcohol. Tertiary alcohol. Tertiary alcohol, here carbon with hydroxyl group. Carbon with hydroxyl group is bonded to other 3 carbon atoms. Carbon with hydroxyl group is bonded to other 3 carbon atoms. This one can be in this way. Example, CH3, COH. Let it be right here. CH3, COH, CH3, CH3. Do you see this one? This carbon contains the hydroxyl group. It's bonded to the first carbon, the second carbon, and the third carbon. So this is called tertiary alcohol. So it is very simple. So these are alcohols. It is important for you to know these classes as we are proceeding. Now, after we have discussed about the classes, let us see the homologous series. Homologous series of alcohols. Do you remember when you talk about homologous series, a list of organic compounds which differ from one another by a constant group, and that is CH2 group. So alcohols also differ from one another. The members of alcohol differ from one another by a constant group, that is CH2. Now here in homologous series, we are going to consider 5 members of alcohol. Now these 5, according to your level. Number 1, we have methanol. Now it is important to know the general molecular formula. Sorry, before we talk about this one, let me write you the general molecular formula of alcohol. It is important for you to know that. General formula of alcohols. This is the one, CN, H2N plus 1, then OH. This one. So it can be written in a similar way as alkane, but it has got 1 less hydrogen atom, because that hydrogen atom, its position has been taken by OH. So this is the general molecular formula of alcohol. So we can use this one to get these members of alcohol. Now starting with the first one, we have methanol. Methanol is the first member. Meth means 1 carbon. Then anol means this methanol is an alcohol containing 1 carbon atom. So you can put it in the formula here. So if we put here, that means N is equal to 1. We put it here. N, that means carbon is 1 here. How about this one? Hydrogen, 2 times N, 1 is 2. Plus 1, 3. So hydrogen is 3. Then you write OH. Can you see that one? So it is simple for you to consider this one. That is the first example. Of the homologous series of alcohol. The second one, we have ethanol. We have ethanol. That one. Now this ethanol can be written that way. The general molecular formula is this one. This eth means 2 carbon atoms, but anol, it means it is an alcohol. So ethanol is an alcohol with 2 carbon atoms. That's the meaning of ethanol. So if we use the general formula to write the molecular form of this one, it is N here is equal to 2. Therefore, it will be C, N here 2. You put here 2. Then hydrogen, H. 2 times 2 is equal to 4. Plus 1, 5. So here is 5. Then you finish with OH. This is the molecular formula of ethanol. We go to another one. Another one is propanol. 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 Now propanol, prop means 3. So here it means, and anol means alcohol. So it means this compound is an alcohol with 3 carbon atoms. That's the meaning of propanol. So N here is equal to 3. That means the number of carbon atoms are 3, represented by prop. And anol represent alcohol. So using the general formula to write the molecular formula of propanol is very simple. C, here N is 3, this one. Then H, here, 3 times 2 is equal to 6. Plus 1, 7. So 7. Then OH. You can see that one. Now, can you note the differences? Look here. Carbon is 1, carbon is 2. So there is a difference of 1 carbon atoms. But how about hydrogen? Hydrogen. Here there are 3 hydrogen atoms, apart from the hydrogen atom from the hydroxyl group. And here we have 5 hydrogen atoms. So there is a difference of 2. And here we have 7, as you see. And this is the homologous series. The members differ from one another by a constant group, that is CH2 group. That one. The last one is butanol. You can finish with the pentanol, but I'm going to give you the last example about it. Butanol. N is equal to 4, but this but means 4. That means this is an alcohol with the 4 carbon atoms. Now to write the molecular formula of it, we use this general formula. C, it is 4. Yes. And hydrogen, 2 times 4, 8. Plus 1, 9. So we have H, 9. Then OH. So it is simple to write this molecular formula. Now after we have seen this one, can we represent these ones using the open structure and condensed structure? It is important as well to see how they are written, because some of the students, they don't know how to write these structures properly. So this will give you the knowledge when you are writing these ones. So when you meet with the compound propanol, it is very simple for you to write them. Now let us go together to see how they can be written. Now here we have this one. This is the alcohol. Alcohols. Here we have molecular formula. Molecular formula of it. Here we have the open structural formula. Here we have the condensed structural formula. Condensed structural formula. So this is what we have. Now after we discuss that one, then you go to the first one. We have discussed about them, so I can write them in a simple way here. We have methanol. Methanol, the molecular formula is this one, coming to methanol. Remember this formula? Plus 1 OH, methanol, 1 carbon, hydrogen. Here we have 2 times 1, here we have 3 OH. This is the molecular formula of methanol. So when you write the open structure, you write this way. Here is OH, here is H, here is H, here is H. There is no problem with that one. Now writing the condensed structure of each one, of that one, CH3, OH. Carbon with 3 hydrogen atoms. Now from there we proceed to the next one. The next one is ethanol. We have written the formula of it a few minutes ago. Here is C2H5OH. Even when you put here 2, here 2 times 2, 4, plus 1, 5 OH. This is the molecular formula. Open structure. How many carbon atoms are here? There are 2. So you write them 1, 2. The OH that one. Because it is present on the first carbon atoms as the name here it reads. By the way, this can be the first carbon or this can be the first carbon because we have only 2 carbon atoms, so there is no problem. Then you put the hydrogen atoms to balance the valence of carbon. This one has used 1 valence. So how many remains? 2, 3. So you put 3 hydrogen atoms that way. So the valence of carbon, 1, 2, 3, 4. It is filled. This carbon, 1 valence, the second one. So it has used how many valence? 2. Remained 2. So you put 2 hydrogen atoms in that way. So you come here, there are 2. Hydrogen, 1, 2, 3, 4, 5. And OH, it is here. Now to write the condensed structure of this one, then you say C, this one, with carbon atoms here, we have 3, as you can see. Then this C, there are 2 hydrogen atoms here, as you can see. Then we finish with what? With OH. So there is no problem. I can give you the last example on how to write this one. This is enabling you on how to write the molecular formula, the open structure formula, and the condensed structure of the given alcohol. So there is no problem. It is important for you to exercise this one so that whenever given the questions to write the open structure of it, you can write. To write the condensed structure of it, you can write without any problem. Now going to the third one. The third one is propanol. Propanol here is the molecular formula. Prop means 3 carbon atoms. Hydrogen, 3 times 2, 6, plus that one becomes 7. OH, this one. So when you write the open structure of it, how many carbon atoms? 3. So you write 3 carbon atoms. 1, 2, 3. OH group present on the first carbon atoms as it is written here. If it could be placed in the second carbon, it should have been stated here by showing the position of it, of the position of the hydroxyl group. But because it is not restated, that means it is present on the first carbon. It can either be this one or this one. It depends with your choice. There is no problem with that one. So if I decide to make this carbon to be the first one, I write it there. Therefore, I fill the valence of carbon atoms by putting the number of hydrogen atoms needed per each carbon. Now this carbon has used 1 valence, remain with 3. So we put 3 hydrogen atoms. This carbon here, 1, 2, has used 2 valence. So we put 2 hydrogen atoms that way. How about this carbon as well? Has used 1 and this 2 valence. So we put 2 hydrogen atoms. So there is no problem with that one. Now to write the condensed structural formula of it, then there is no problem here. You can come and write C, this carbon. How many hydrogen atoms does it have? 1, 2, 3. So you write them in this way, the 3. This one, C. How many hydrogen atoms? There are 2. So you write them in that way. And this one, C, there are 2 hydrogen atoms, that one. And then you finish with OH. It has got 3 hydrogen carbon atoms, 1, 2, 3, and it has got 7 hydrogen atoms apart from the one coming from hydroxyl group, 7. 1, 2, 3, 4, 5, 6, 7, and we have hydroxyl group. As you can see here, 1, 2, 3, and this is 5, 7, and then the OH. So this is a very simple way for you to write the structural formula of this one. So you can have this knowledge of writing the open structural formula and the condensed structural formula. It is very simple in that way. Now, after we have seen the way of writing these structural formulas, now let us see the nomenclature. Let us go to nomenclature. Nomenclature, the system of naming given by International Union of Pure and Applied Chemistry. This is this one gives the rules of naming alcohols as well. Now here we have the rules. The rules of naming alcohols are the same as those in alkane, but few modifications can be made. By the way, these alcohols systematically they are called alkanols. That is the systematic names of alcohol. Alkanols. It is also important for you to know this one. Alkanols. The system of naming this one, you select. Let me remind you. Select the longest continuous chain with hydroxyl group. That is important. Make sure that the chain that you are selecting has got the hydroxyl group. If you don't do that, you're going to be wrong. That is number one. Number two, numbering of carbon atoms. Numbering of carbon atoms should start from the end, closer to the hydroxyl group. So numbering of carbon atoms should start from the end closer to the hydroxyl group. That is very simple. You can do it. Number three, we are going to see some examples. Identify the substituents. If there are substituents, remember what are the substituents? If I to ask you that question. These are atoms or group of atoms which are bonded to one of the carbons in the continuous carbon chain or in the continuous longest chain. So there is no problem with that one. And the common one, we are talking about alkyl groups. Now the third one, identify the position of, first, identify the substituent, identify the substituent group and their position. Substituent groups and their position. So these are the very simple ones for you to understand. So the position, that means at what carbon from the side with hydroxyl group is that substituent is bonded. That is also very important. Now if the substituent groups are present more than one but are of the same, you can use the suffixes, the prefixes like di to means two if they are two. You can use the word tri. So this one, tri, this means three. So for example, if you have three methyl group, then you say trimethyl. There is no problem with that one, which is very simple. Now let us see how the nomenclature can be done. Let's go to examples, to questions to see how we can do, how we can name different organic compounds. Let's go to question number one. Question number one says, give the International Union of Pure and Applied Chemistry name for each of the following. You have the first one, CH3, CH2, CH in bracket. The bracket, this bracket means this methyl group is bonded to this carbon. That is the meaning. CH, we have this group, this bromide group. So it is attached here to carbon. We have CH2OH. So this is an alcohol. How to name that one? It is very simple. Now let's come on the board to see how you can do that first part. Now, question number 1. Here we have question number 1, Roman 1. We have CH3, CH2, we have CH. Let me write it the way it is, and then I will come to put it properly. Then CH3, then CH that way, then CH2OH. Yes, CH3, CH2, CH in bracket, CH3, CH in bracket, this is bromide group, and CH2OH. So this one is also written in this way. CH3, CH2, C. This methyl group in bracket is bonded to this carbon atom. Then H. Going with this one, H. Now this bromide group here in bracket, it means it is bonded to this carbon here. Very simple like that one. Then we have CH2OH. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the compound. How do you name this one? It is very simple. Now, you select the longest continuous chain. 1, 2, 3, 4, 5. 1, 2, 3, 4. Automatically, this is the longest continuous chain because it contains a large number of carbon atoms. Remember, when we talk about the longest chain, we are talking about the chain of carbon atoms only, and not halogens. Therefore, numbering of carbon atoms should start from the end, closer to the hydroxyl group, as we have said here. Numbering of carbon atoms should start from the end, closer to the hydroxyl group. Therefore, this is carbon number 1 because it has got the hydroxyl group. This is carbon number 2, carbon number 3, carbon number 4, carbon number 5. If this is the longest chain with the 5 carbon atoms, therefore, these are the substituents. This one at carbon number 2, this one at carbon number 3. Therefore, you name. Because there are 2 different substituent groups, you name them alphabetically. If they are of the same, there is no problem. But if they are more than 1, but they are different, then you follow the alphabetical order. Which one starts alphabetically? For example, we have this B, and this is M, methyl. Therefore, this one will start. So, at the second carbon. So, you first show the position of it. So, here is 2 to show the position of this group. Then you put an hyphen there. Don't put this one. You put an hyphen there. Then you write the name of this one. It is called bromo. Bromo. That way. Then from there, you have finished with it. Then you go to another one. You put an hyphen to separate it. You go to methyl group, but you show the position of it at the carbon number 3. So you say 3. There is only 1. So because they are finished, you write an hyphen, then you write the name of this one. It is methyl. Methyl. From there, then you finish, because we have finished with the substituent groups, then we finish with naming the parent chain. So this is 1, 2, 3, 4, 5. So this is pent dash. Then we finish with 1, sorry, this is pentan, 1, all. Therefore, this is the formula. So you have to end up with all to show that this is an alcohol. So there is no problem with that one. Now, after we have finished with the first one, we go to the second one, the second part. The second part, it is here. The second part is this one. Here we have CH3, C, OH bracket, methyl group. What is the meaning of that one? That means this carbon is bonded to OH and also bonded to methyl group. Then we finish with the CH3. How is it written? Now let's be on the board to see how this one is written. So that one is written as CH3, CH, then OH, then given CH3, then CH3. That is the way that question, sorry, there is no H here. CH3, C, OH, CH3 in bracket, this in bracket, then CH3. That is the way. How this one can be written? It can be written also in this way. CH3, C. Now this carbon is bonded to a hydroxyl group and also bonded to methyl group. Methyl group. Therefore, this one, we finish with that one. So this is the meaning. So this bracket means these two, this substituent is bonded to this carbon and this hydroxyl group bonded to this one. Now from there, how many carbon atoms do we have in the parent chain? 1, 2, 3. So there are 3. If there are 3, the hydroxyl group is present on the second carbon. If you start from this end, the second. If from this end, the second. So you can start from either side. There is no problem with that one. Now from there, we can give the name. Starting the name of the substance, this is methyl group. In the position, if we start here, 1, 1, 2, 3. So you start naming 2 to show the position of this methyl group, dash, because it is only 1. Then you put methyl group. Then you name the parent chain. This is propan. You write propan. Then you finish by putting a hyphen to show the position of the hydroxyl group. It is present on the second carbon. Therefore, it is 2. Then you finish with all. This is the way of naming these organic compounds. As you can see, 2-methyl, then propan, 2-all. 2-methyl, propan, 2-all. There is no problem with that one. So that is the first part. Now from there, it is important for us to consider about the isomerism. Isomerism in alcohols. Isomerism in alcohols. How do you write isomerism in alcohol? It is the same as we have been discussing. But here, to get the isomers, isomers can be obtained by techniques number 1, changing the position of hydroxyl group. That is number 1. Number 2, take carbon atom with its hydrogen atom and make it as a substituent. So these are the 2 rules. Changing the position of the hydroxyl group, take carbon atom with its hydrogen atom and make it as a substituent. So here, let us apply those 2 techniques. The first member, that is methanol and ethanol, have no isomers. The isomers, we start with examples. Now let's go to the question to see how to do this one. Now let's go to the question. Now can you see this one? What are the possible isomers for each of the following compounds? We have butanol. I'm going to show you one, and the rest you can do it by yourself. Let's start with butanol. Butanol. The molecular formula of butanol, you write it using this general formula of alcohol. Butanol is C, because but is 4, it is 4 here, and 2 times 4, 8 plus 1, 9, or H. This is the molecular formula. Now, starting writing the isomers now. Number 1, you write the structure of that one. How many carbon atoms? There are 4. 1, 2, 3, 4. So there is no problem. So you feel, if you want the hydroxyl group to be in the first carbon, there is no problem. You can choose this one or this one. Then you fill the hydrogen atoms. This one needs 3 hydrogen atoms. This carbon has used valence 2, 1 and 2, needs 2 hydrogen atoms. This carbon has used 2 valence, this and this one. It needs 2 hydrogen atoms to make it 4. so you put hydrogen atom there too. And this one, valence 1 and valence 2, it needs 2 hydrogen atoms. So the number of carbon, 1, 2, 3, 4. As you can see, hydrogen atoms, 3, 5, 7, 9. This one, and OH. So this one is called butan 1 all. When you name this one, 1, 2, 3, 4. Butan 1 all, because hydroxyl group is present on the first carbon. Now going to the second one, you change the position of hydroxyl group. Can you put in the second one? Then you are going to have this 1, 2, 3, 4. This hydroxyl group on the second one. Then you fill the number of hydrogen atoms per carbon. That one. How many are carbon atoms? 1, 2, 3, 4, as they are here. Hydrogen atoms, 3, 5, 6. Sorry, 3, 5, 6, 9, and OH. It is there. To name this one, it is present on the second carbon. So this is butan dash 2 all, because hydroxyl group is present on the second one. So it is very simple. Now, can you proceed giving the isomers of it? It is very simple. Now, let's go on. We can take this one, and make it as a substitute. Shifting the position of hydroxyl group is enough, because if you put here, we're going to get the same name. So let's take this carbon and this hydrogen atom to make it as a substituent. Let's say we put it here. So we are going to have this one. We are going to remain with 3 carbon atoms on the chain. So we have taken this one, we put it there. So hydroxyl group is there. So you fill the valence of hydrogen that way to make it that way, to fill the valence of carbon. So one carbon, 1, 2, 3, 4. Therefore, hydrogen, 3, 6, 7, 9, as you can see there. Naming this one, the first carbon has got a hydroxyl group, the second one, the third one. So in the second carbon, you have methyl. So 2-methyl. 2-methyl, you finish with what? Propan 1 all. You can see 2-methyl, then carbon 1, 2, 3. Propan 1 all. This is the name of that one. Now, can you finish this one? Take a piece of paper and try. Still, we have one more isomer here. Yes. Now, number 4, let us write it. Now, change the position of hydroxyl group and put it there at the second carbon atoms. So we remain with 1, 2, 3. So if this hydroxyl group is taken there, and this is a substituent, so we are going to have a different structure. So you fill the valence, you fill the number of hydrogen atoms here in order to fill the valence of carbon. So here you name it 1, 2, 1, 2. You can start from either side because hydroxyl group is present closer to both ends. So if we start here 1, 2, 3. So the parent chain is having 3 carbon atoms. Therefore, we are going to say 2-methyl. We start with the substituent group. This is 2-methyl. 2-methyl. Then propan dash. You show the position of hydroxyl group in the second carbon all. This one. 2-methyl. Then propan to all. It is very simple to write that one. Now, after we have seen the isomers, how to get the isomers, now can we proceed to other part, to see the other reactions? To see other questions. For the case of the chemical reactions of alcohols. Let's go to see the questions which show the chemical reactions. Now here, to see the questions, complete the following reactions. We have this one. This is ethanol reacting with the concentrated sulfuric acid at that temperature, 170 degrees Celsius. We have the second one, CH3, CH2, CH2OH with the oxygen. We have potassium reacting with the CH3, CH2OH. We have reacting with This is acid. It is called ethanoic acid. We are going to see about that one in the coming lesson. So let us see how to go through those questions on the board here together. So here the question, Roman 1, is talking about, this is to Roman 1, is talking about CH3, CH2, OH, reacting with concentrated sulfuric acid. The temperature is 170 degrees of Celsius. What happens to this reaction? Concentrated hydrochloric acid can be used as a drying agent. So this is a dehydration reaction. Dehydration process. It involves the removal of water molecules from alcohol. So the elements of water, that means hydrogen and oxygen are removed by this acid, which is concentrated. So this is the drying agent. It removes the element of water. That means take away the element of oxygen and hydrogen. So we can write it in this way: CH3, CH2, OH plus concentrated sulfuric acid. What will be the product? Degree of Celsius. Let me write the product here. But the condition which favors this reaction to take place is this one, 170 degrees of Celsius. If this condition is not there, this reaction or dehydration process won't take place. So that is very, very important to consider when you are given this kind of reaction. So the elements of water will be taken away. And when the elements of water are taken away, what will happen? A double bond will be formed from this one. So there is a very simple thing for you to do here. A double bond will be formed. Here, CH3, CH2, the product will be, because we have two carbon atoms, hydrogen and oxygen will be taken away. So we are going to form the double bond this way, plus water molecule. So it is simple for you to do that equation. So it is simple like this way. Remember the temperature. But this temperature can range from up to 180 degrees of Celsius. So it is very simple. It depends with the number of carbons. Here the carbons are 2. Here. So this double bond will be formed from that reaction. That is number 1. Number 2. Question number 2 is CH3, CH2, CH2OH reacting with oxygen gas. This is the combustion equation. So combustion reaction. When all alcohols burnt in oxygen, the product carbon dioxide and water. So with that one is very simple. CH3, CH2, CH2OH with oxygen gas. Now what will be the product? Let me write the product here to finish with this one. So the product will be a carbon dioxide and water. These are the products of combustion. So you balance the equation. How many carbon atoms? 1, 2, 3. There are 3 carbon atoms. So if there are 3 carbon atoms, then you put here 3 to make it 3 carbons. How about hydrogen? This is 3. This is 5. This is 7. This is 8. So you put here 4 to make 8 hydrogen atoms. How about oxygen? So you can balance by putting here 9/2. Then we come 1, 2, 3, 3 carbon atoms. Hydrogen 5, 7, 8 hydrogen atoms. Oxygen, here this and this one we cancel, we are going to get 10. Here is 6 plus 4, we get 10. So it is very simple in that way. Now another part of the question is to finish with that one. CH3, CH2OH reacting with CH3COOH. Now this is called ethanoic acid. Ethanoic acid. And this is ethanol. When ethanol and ethanoic acid react, that means this is alcohol a reaction between alcohol and carboxylic acid. Carboxylic acid. We are going to see later about this carboxylic acid. We get ester and water. So this is esterification reaction. Esterification reaction. The reaction between alcohol and carboxylic acid to get ester and water. So what will happen? This acetic acid will release hydrogen ion, and this alcohol will release hydroxide ion. This ion will unite with this one to form water. So this one will be taken here. So we are going to have the following product: CH3, CH2, OH plus CH3, COOH. We are going to form the following. There should be a condition, acidic condition for this reaction to take place. This can be sulfuric acid. So here we are going to have CH3, COO. This is an acid, carboxylic acid. This hydrogen and this OH will form water. So there is water here. So this remaining, this H2 will start here. We have CH2, then to finish with CH3. So this one. So this is ester. It is called ethyl ethanoate. It is an ester. Ethyl ethanoate. Remember, this one and this one will form water. This one will come here to make CH2, CH3. So it is a very simple one, as you can see. Ethyl ethanoate. Now the last part of the question is very simple. You can do it by yourself. Now let me take this opportunity to thank you for watching this program. You can have more reading from these books. You can have more reading from here. Chemistry for Secondary Schools, Book 2, 1995 tie. Chemistry for Secondary Schools, Form 4, Revised Edition, 2011, Oxford University Press, Tanzania Limited. For more readings. Have a good time.